I stored every conversation in a vector database expecting the agent to remember, but it did not. Today, we will reproduce this exact memory conflict step by step and then build a state-aware consolidation layer to fix it once and for all. Building an assistant to track customer preferences over months showed me how rapidly raw vector memory decays. In practice, after 30 days of passive retrieval, operational accuracy drops to 49% due to a 38% memory staleness rate. We can easily isolate this bug by writing two sequential statements from user Alex into an append-only database. First, in January, Alex says, "I hate milk. I only drink black coffee." Then in July, Alex says, "I now like oat milk lattes." Querying the database retrieves both conflicting statements with nearly identical similarity scores. The vector search returns Cosine scores of 0.89 and 0.88. The agent gets confused, defaults to the strong keyword, and fails by serving black coffee. A raw vector database is just a chaos warehouse of unlabeled boxes. Retrieval pulls up everything containing similar keywords. A heavy magnetic claw called Cosine Similarity grabs old and new boxes alike, leaving your agent completely baffled by the contradictions. The root cause is that similarity search measures semantic closeness, not validity, truth, or chronological recency. State management is left entirely unhandled. This explains why frontier models score only 55.2% on the state-aware memory benchmark. To fix this, we must decouple episodic raw logs from structured semantic facts. We refactor our database schema, moving from unstructured text chunks to clean structured memory cards containing fields for the fact, its type, its timestamp, and its current active status. Next, we build an adversarial write-time consolidation block. When the new oat milk preference arrives, it triggers a semantic scan, detects the direct conflict with that January black coffee record, and immediately invalidates the old card by setting its status to inactive. Finally, we modify our query layer to enforce a strict metadata filter. When we query the vector store, we construct our search to only fetch cards where the status field is marked active, discarding outdated details entirely. Rerunning our identical test, the query successfully filters out the stale January preference. It retrieves only the active oat milk latte card. The agent has the correct context, instantly knows the current truth, and successfully serves the correct drink every time. This state-aware consolidation fix does introduce about 1.5 seconds of additional write latency due to the auxiliary reasoning pass, and it requires managing a structured database schema. But in exchange, you will get completely clean query context and perfect temporal consistency. When you are designing your own long-term agents, always remember this single rule: memory is a decision system, not merely a storage system.